Okay, welcome to day 4 of Advent of Code. This one we are dealing with scratch cards. So here we can see the gondola has taken us up and rest of the story, blah blah blah. Not going to read all of this through. But we get to a pile of colourful cards and you discover dozens of scratch cards, all of their opaque covering already scratched off. Picking one up, it looks like each card has 2 lists of numbers, separated by a vertical bar. And a list of winning numbers, then a list of numbers that you have organised. You organise the information into a table, which is your puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have to appear. Each of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point. Each match after doubles the points value of that particular card. So we take the first card. It has 5 winning numbers: 41, 48, 83, 86, and 17. And 8 numbers that you have. Of the numbers that you have, 4 of them are the winning numbers. This means that card 1 is worth 8 points, 1 for the first match, then doubled 3 times for each of the matches after the first. So card 2 has 2 winning numbers, 32 and 61, it's worth 2 points, so on and so forth. So in this example, the elf's pile of scratch cards is worth 13 points. Take a seat in the large pile of colourful cards. How many points are they worth in total? So for this particular one then, for each of the matching cards that are here, you get a point if they are in the left-hand side. If it's 2 matching cards, you get 2 for the second. 3 matching cards is 4, so on and so forth. It keeps doubling up to as much as it doubles. So let's dive in. Okay, so if we open up part 1. So I've already popped in the test input here for us, ready to go. So I thought this puzzle was relatively easy. Let's go through how I did it. So firstly, what we want to do is we want to iterate over the cards. So let's do for card in string.split lines. I've also turned off auto completion of the LSP just for now, because as you can see in my previous videos, it was playing a bit of havoc, so yeah, turned it off for now. I'm also kind of going through a bit of a revamp of my NeoVim config, which I'll get to at some point, posting a video about. But anyways, for now, so for card in string.splitlines, what we want to do is we want to get the card total, initialize it to 0 to start with, winning cards, and the cards that we have is either side of this split here. So if we firstly say card, and if we do card.find, and finds the we could just do dot strip the prefix with regular expression, because we don't know how many card numbers there are going to be. I decided to just do it this way, finding the colon space, which is this part here, and then that will we can then, off of the back of that, so we want to go from there to the end. Off the back of that, we can then just split the left and right quite easily. So if we then just do dot split, and we want to split that on pipe. So then again, we want to split the winners. We want to split each of these really by space. We do have some extra space in here. So what we might want to do is just strip out the spaces. So we could strip out the extra spaces. So winners equals, let's do a list comprehension. So if we do w dot strip for w in winners dot split by a space. So this will initially split by a space and then get rid of all of the spaces. That might actually give us an extra one there. So let's not do the strip. Let's just do if w does not equal an empty string. Cool. Have is equal to have h for h in have dot split if h does not equal an empty string again. So that again accounts for the extra bit of space in there. Cool. So then what we want to do is for h in have, if h in winners, we want to then increase the card total. So we want to do card total is equal to 1 if the card total equals 0, if it's the first one that we're doing. Else we want the card total multiplied by 2. Cool. And then at the end of that, what we want to do is just do total plus equals the card total. So hopefully we can run part 1. We get 13 and we get 21568. So yeah, here we have 13 and 21568. So we know we've got those two correct there. Yeah, so all we did here, I think I said earlier that it's incrementing up the doubling, but actually it's doubling the card total, not the doubling each time we're adding 1. Very subtle little differences there. Initially what I think I said was this would be, if this matched it would be a 1, if this matched it would be a 2, if this matched it would be a 4, if this matched it would be an 8, so on and so forth. But it's actually doubling the count of the card, or the total for the card, for every subsequent one after the first point. Very small differentiation, but yeah, there we go. So that is part 1. As you can see, we had some leftover stuff there from the other day with the regex. Cool. Okay, so if we then head on over to part 2, so with part 2, what we need to do, as you're about to report your findings, the elf, findings to the elf, one of you realises that rules have actually been printed on the back of every card this whole time. Excellent. There's no such thing as points. Instead, scratch cards only cause you to win more cards. Specifically, you win copies of the scratch cards below the winning card equal to the number of matches. Yeah, I remember this one was fun to figure out. So if card 10 were to have 5 matching numbers, you would win 1 copy of each of the cards, 11, 12, 13, 14, and 15. Copies of the scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of card 10, it matches 5, has 5 matching numbers, it would win a copy of the same card that the original card 10 won, cards 11, 12, 13, 14, and 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. So, this time it goes a little bit differently. Card 1 has 4 matching numbers, so you win 1 copy of each of the next 4 cards, 2, 3, 4, and 5. Your original card 2 has 2 matching numbers, so you win 1 copy of 3 and 4. Copy of card 2 also wins a copy of 3 and 4. Your 4 instances of card 3, 1 original and 3 copies, have 2 matching numbers, so you win 4 copies of 4 and 5. Your 8 instances of card 4, 1 original and 7 copies, have 1 matching number, so you win 8 copies of card 5. Your 14 instances of card 5, 1 original and 13 copies, have no matching numbers, win no more cards. Your 1 instance of card 6, 1 original and no matching numbers, wins no more cards. Once all of the originals and copies have been processed, you end up with 1 instance of 1, 2 instances of 2, 4 instances of 3, 8 instances of 4, 14 of 5, 1 of 6. In total, this example pile of scratch cards causes you to ultimately have 30 scratch cards. Process all of the original and copied scratch cards with no more scratch cards are 1, until no more are 1. Including the original set of scratch cards, how many total do you end up with? So this is a nice fun little extra challenge. So, how did I do this one? Well, this one I think caused me some headaches initially, trying to kind of figure through it. It sounds really easy, and so I think the approach that I did was okay. It could have been a lot better. I definitely think I definitely remember seeing some other people explain their examples with much shorter amounts of code, but yeah, let's give it a go, shall we? So, what we have here then, if we're going to need to keep track of how many times each card is copied. So if we make a card count dictionary on the top here, cards is equal to input string dot split lines, and then final cards equals this. In fact, I'm not sure if we're going to need final cards. Yeah, actually, let's keep it there. Okay, so what we need to start with is just going over all of the cards, but also keeping the ID of the card. we don't necessarily need to keep this specific card ID, but it would be useful for us. Instead, the way that I did it was just enumerate over them, starting at 1, because it's just going to go up in order. So for card ID and card in enumerate, cards starting at 1. Firstly, let's just append the final cards, just to say that it is that it's in there. I think we can probably keep a count of it there. In fact, I don't think I end up using this, but we'll see. Final cards, append card. So this one's just going to go in there. Cool. So then what we want to do, if the card ID is not in card count, then card count of card ID is equal to 1. Else card count card ID plus equals 1. We could use a default dictionary here as well, but keeping it simple with these. So this is just going to increment our count for the cards if we haven't already seen it, and then if we have seen it, we're just going to increment by 1. Cool. Okay. So card total equals 0. Cool. So now we want to split out all of the parts again, like we did before. So we have the winners and have is equal to card dot find. We want that. We want to go to the end. We want to then split it on pipe. Cool. Winners is equal to W for W in winners if winners dot split by space if W is not equal to an empty string, and have is equal to H for H in have dot split if H does not equal empty string again. Cool. So that will just get rid of all those nasty extra spaces, or the usage of those. Cool. So for we don't really care about this variable. So in for underscore in range, we want to go to the card count card ID. So we're just going to repeat this same thing the amount of times that card has been listed. So initially we've got 1. So if we're on card 1, we're going to do this 1 time. So in range 0 to 1, so 1 time. Else we're going to do it however many times it's been listed here. So, for example, as we go through and add the extra cards in, then what we'll do is say we get to 2, 3, 4, and 5 from the first card. So original card 2 is going to have the original 1 that gets added, but it's also going to then have 1 incremented, so it's going to then be 2. So 0 and 1 because of this range. So it will repeat this whole thing 2 times. Repeat 3, 4, 5 for however many times it needs to be done for each of the cards that have been duplicated. Cool. So for each in have, we're then going to if H is in winners, card total plus equals 1, because we set it up here to 0. So for every matching card, we want to increment it by 1. So then what we want to do is we want to say for I in range 1, card total plus 1. We are then going to do our incrementation. So if card ID plus I is in card count, I'm going to do card count card ID plus I plus equals 1 else, and then this is where we're going to then set it initially. So card count card ID plus 1 plus I is equal to 1. There we go. Cool. And then we simply card total minus equals 1. Yeah. Cool. So then that will give us all of the cards that have been added in. So then if we just do the sum of card count dot values like that. Okay, so then if we run part 2, we get nothing. Okay, so what went wrong? What went wrong there? Oh, I'm still returning total. So what I actually want to do, that gives us 30, which is correct. It just takes a very long time to run for the actual answer. Give it another few seconds to see if it finishes. I think this is why my approach isn't the best, because each time we're repeating things. There we go. We're keeping looping over the same thing multiple times. This is just not a fast way of doing it, but I didn't I didn't actually do an optimized solution for this one, but I'll probably come back and do one at some point. So we have 30 here, and we have 118.27296 just there. So you saw how long it took for that to run. Like I said, I'll probably come back at some point and do a better, more efficient approach. But yeah, cool. Right. Thanks for watching part 4, or day 4 even, of 2023 Advent of Code. Cool. See you on the next one.